Good morning, everyone, and welcome to the SQLite and TCL 2020 virtual conference. My name is Karl Lehenbauer, and I am the co-founder and Chief Technology Officer of FlightAware. I am also one of the inventors of TCL, not the primary, who is John Osterhout, Professor of Computer Science at the University of California at Berkeley. I've been using TCL since version 1.0. For better or for worse, I invented how files and sockets work in the language, as well as arrays, inker, upvar, lassign, subst, and unknown, and am the author of numerous packages and C extensions. This is the 27th annual TCL conference, which in itself is kind of amazing. The plan was to have the conference in person, as we have done for the preceding quarter century, but of course, due to COVID-19 virus that is currently impacting people all over the world, it became clear over time that asking people to travel to an in-person conference this year would be asking them to put themselves in an unacceptable risk and wasn't really feasible. Simply canceling the conference would have been the easy way out, but we would have lost something important and valuable. Every year for the last 26 years, we come together to communicate and share information about the TCL language, but also we come together as a community. Many of us have become friends over the years, and some of us have been for now well over 2 decades. The conferences haven't just been an opportunity to find out more about TCL and share and get informed about and build upon each other's work, but also to experience the pleasures of being a community. Often after a day of technical presentations, breaking bread together and staying up late into the night, chatting, hobnobbing, and brainstorming until the wee hours. Rather than canceling the conference, we elected to create a virtual one instead. And although we can't be together in person, we can still be together. And it occurred to me that while we do get to come together in person once in a while, the vast majority of our interactions over the entire existence and evolution of the language have been online, via email, Usenet, seeing and reading each other's code commits, and the occasional phone call. I remember at the first conference, for the first time, putting faces to the email addresses of people I'd been corresponding with. It was exciting and sometimes a little surprising. Compared to what we had before TCL 1, this is way better. We can see and talk to each other in real time from all across the world. Let's talk about TCL for a second. According to the TIOBE Index for November of 2020, TCL is the 45th most popular programming language in the world. That may not seem super impressive at first glance, but the Online Historical Encyclopedia of Programming Languages documents the existence of 8,945 programming languages. Some estimates say there are as many as 25,000 programming languages in active use. Going with the more conservative number puts TCL in the top 0.5% of all active programming languages by popularity. I don't know about you, but I think that's super impressive. You don't normally see TCL when you see a computer application, just like you don't know if a machine has an Intel processor inside unless there's a decal on the box. But sometimes I do see it, and I know it when I see it. I see the bisque color and the unique decorations of a TK application at the place where I get my hair cut. And when I got a tour of NASA, I recognized TCL TK on the displays in Mission Control and Space Station Control and confirmed it using Google once I got home. It's quite an accomplishment, and I want to acknowledge all of you who have had a hand in making TCL more popular than 99.5% of the languages in active use. Thank you. You may have noticed I keep saying TCL when all of you know it's pronounced Tickle. Well, a marketing woman, an expert, whom I respect, said to me a while back, "Your language is called Tickle? A bunch of grown men talking about Tickle? That is weird." I would pause here for laughter if we were together in person. I came to the conclusion that she's right. A bunch of grown men and women talking about Tickle is weird. Consequently, I invite everyone to join me in doing a soft rebranding of Tickle to TCL, and I intend to refer to the language going forward as TCL, although old habits are hard to break and it's going to take some time to get used to. Now I'm going to speak for a minute about SQLite. As most of you know, SQLite was written by Richard Hipp, and for a few years now, one additional full-time guy and one part-time guy. Richard will be speaking next. I've heard Richard say on more than one occasion that SQLite is the second most widely deployed piece of software in the world, with the most widely deployed one being the zlib compression library. But the zlib library is just a compression library. It's pretty simple. So I'd like to put it this way. SQLite is the most popular, broadly distributed, and widely used piece of programmable software ever created in the history of humankind. It is without a doubt the most widely deployed SQL database engine in the world. Billions of copies of SQLite exist. SQLite is found on every Android device, every iPhone and iPad, every Macintosh, and every computer running Windows 10. It's used by every instance of Firefox, Chrome, and Safari, and every instance of Skype and iTunes. It ships with TCL, with PHP, and with Python. It is in most television sets and most set-top cable boxes, in most automotive multimedia systems, in the avionics of the new Airbus A350, and in millions of other applications. Since SQLite is used extensively in every smartphone, and there are roughly 3.5 billion smartphones in active use, each holding hundreds of SQLite database files, it seems likely that there are over 1 trillion SQLite databases in active use. It is so popular, so stable, so clean and well documented, and so pervasive that the U.S. Library of Congress has declared it as a recommended storage format for datasets, one of only 4 such formats, and the other 3 are XML, JSON, and CSV. When I was in high school in the early mid-1970s, I had a job as a COBOL programmer at an auto parts retailer that had 100 stores and 1,000 employees in a huge warehouse, and we operated the business with a single tasking computer that had 12K of memory and 2 10 meg removable disk drives. I bought a book about this thing called structured query language. It was theoretical because SQL database implementations didn't yet exist. I found the book very frustrating because I didn't understand it, and I didn't have anyone to talk to about it, but I read it and I read it again. Over the years, as SQL database servers began to emerge and I began to use them, it started to dawn on me that except for the formatting of output, all of these COBOL programs that I wrote and or worked on, multi-100-line programs, multi-1,000-line programs in many cases, programs that required their input files to be sorted in a certain order before they could be run, programs to print orders, to print price tags, to print people's paychecks, all could be replaced by simple SQL queries. Select star from orders, left join stores, yada yada. Thousands of lines of code replaced by the relational calculus of SQL statements. SQLite is the most popular database engine in the world because of some unique features that it has. That it is a library and not a server. That it doesn't require a database administrator. That it is fast. That it is compact. That it is featureful and robust. And in no small part that it is free. The power of SQL is available to pretty much every application developer in the world. Think about that for a second. Game developers, mobile app developers, moving map display developers, avionics developers, millions of developers save themselves from having to write hundreds or thousands or hundreds of thousands of lines of custom code to manage data stored in flat files, just as I was having to do back in the day. It's really incredible. And it's an even bigger deal than that. With the flat file approach, if the power fails, or the battery runs down, or the machine runs out of memory, or crashes while writing, there's a good chance that the data will be corrupted, or even just from a bug in the program. People would have to be including code to try to repair or regenerate or restore from backup or simply delete their data after a crash. You'd lose your radio presets, your moving map, your high score, and maybe your airplane. Yeesh. SQLite is ACID compliant. Richard and his small team have made absolutely heroic efforts to ensure that in the event of a power failure, crash, etc., all transactions are either fully committed or fully rolled back. Even in the face of memory allocation failures, which can happen on small systems, SQLite will not corrupt its data. This is mind-blowing and one more reason why it is so ubiquitous. You know how when you were a kid and you'd get a new toy for your birthday or for a holiday, and within a day or two, you'd have exhausted all the possibilities of it? SQLite is better than the best toy I ever got. I love SQLite. I just love it. I find it endlessly fascinating, and we have made very heavy use of it at FlightAware. SQLite's initial public release was in May of 2000. Ergo, Richard's been working on it for over 20 years. Can you imagine? Any ordinary man would have gotten bored and given up a long time ago. Most projects that get pushed to GitHub are never used by a single other person. You post your alpha, no one uses it, it more or less vanishes without a trace. I read an article about Bob Metcalf, the inventor of Ethernet. Pretty important technology for the modern world. You may have heard of it. He owns an impressive brownstone home in the Back Bay part of Boston and enjoys having over MIT engineering undergraduates who are like, gee, Mr. Metcalf, I want to someday invent something cool like Ethernet too. And he tells them, well, after I invented it, I had to spend 20 years trying to shove it down people's throats, trying to sell it, trying to get it accepted. And then they don't like hearing that and they want to change the subject. Richard has maintained a single-minded focus on SQLite for 20 years, and he's made a commitment to support it for another 30. And he's not just been developing it and improving it, he's been sharing it, publicizing it, giving talks about it, and answering questions about it for free as recently as yesterday. He has shepherded it to the level of success that it has attained. He's whip smart, but also humble and incredibly generous. So now, without further ado, I'd like to welcome Richard Hipp.
Thank you very much. Thank you very much. Thank you for that kind introduction, Carl. One thing that he didn't mention is that why is SQLite and TCL, why are they combined into the same conference? Well, what he didn't say was that SQLite is really a Tickle extension that escaped into the wild about 20 years ago. So I'm not going to try and project my slides on the screen. I have made them available for you online. So if you can visit this URL, there will be the slide deck. At the top of each page, there's a number, which is the slide number, where it starts at 0. And I will try and remember to tell you which slide I'm on as we progress through it. So take a moment to go and load up the slides. Yeah, and of course, the rule is that you're not supposed to look ahead, right? And you're all going to follow that rule, right? Welcome, everybody. I'm glad that you're here. My brief talk today is just going to be a status report of SQLite. I'm going to talk about what's been going on in the past year. I'm just assuming that everybody here knows about SQLite. You may well be using it in your applications, but maybe you're not. Keeping up with it day to day. And so this is a report of what we've been doing for the past year or year and a half, just to bring you up to speed. So I'm on slide 0. Let's go to slide 1. Yes, SQLite 20 years old. This past spring, code 20 years ago, it was part of a Tickle TK application that I was building at that time. So it really was a TCL application that I was building it. It was originally a TCL extension that escaped into the wild and became a product unto itself. It still uses TCL heavily for testing and code generation, but there's when you bundle SQLite into your own applications, it doesn't require TCL to be present. Slide 2. As Carl just mentioned, we started 20 years ago. And our plan moving forward is to support SQLite for 30 more years. This came about 10 years ago. A customer actually called and said, can you support SQLite for 40 more years? And I said, sure, why not? Now, I'm under no obligation to do that. They're not paying me to do that. But that's my goal. And of course, in this business, who knows what's going to happen? We might be canceled by a Twitter mob tomorrow. Who knows? But the goal is to support this moving forward until the year 2050. And I picked the date 50 years from first code to be the end of support. We'll see how that goes. It might go beyond that. We'll just have to wait and see. But the point is, by my reckoning, SQLite is not even yet to middle age. Let's go to slide 3. I don't know. This is a cartoon, an XKCD cartoon that came out this year. And it's been coming up a lot on Twitter. Whenever people talk about SQLite, they post this an image of this cartoon as well. I don't think that Randall, the author, intended it to be about SQLite, but it does kind of it is kind of apt because SQLite is a key component of a lot of our modern infrastructure, and this explains sort of our attitude and how to change it. People come to me all the time and says, "Richard, can you add this feature or that feature?" And I tend to say no. And the reason for that is that I need to protect the code. There's a lot of things that depend on this code, and I want to make sure I don't break anything. That said, let's move on to slide number 4. This is the releases that have happened over the past year or a little bit over a year. We've got another release scheduled to come out in a few weeks. Our release cadence has slowed. We were doing 5 or 6 releases a year. Now we're down to less than 4. And I anticipate that that release cadence will continue to slow because really there's not a whole lot left to do. I'm responding to a question here. It says, am I in Nebraska? No, I'm suburban North Carolina, in Charlotte, North Carolina. I'm coming to you live from the world headquarters of SQLite, which is actually in the bonus room of our suburban Charlotte home. I wrote every bit of SQLite that I've written from this very spot. For those of you who don't know, a bonus room is the room over the garage, and that's where my office is. So our release cadence is about 4 per year at the moment. It'll be slowing down over time. The page 5. So just some basic stats of where we are at the moment. The current, as you may well know, the SQLite database program is a library, and we package it into a single file of C code, which is 144,000 SLOC, or source lines of code. That means lines of code not counting blank lines and comments. So about 140,000 source lines of code. It compiles, if you compile optimized for size, to between 500 and 600 kilobytes. Now, if you turn on all kinds of optimization, you can make it a lot bigger, but that's the goal. For a long time, I tried to keep it below 500 kilobytes, but we eventually just had to blow through that. And now I'm struggling to keep it below 600 kilobytes. We've been doing it for almost 20 and a half years now, an average of 3.25 check-ins per day, 7 days a week, 365 days a year. In the past year, we've had 1,048 check-ins leading to trunk. Now, we've had additional check-ins on branches, but of those 1,000 check-ins, we have added about 5,000 lines of code. We've deleted about 1,000 lines of code, and we've modified 25,000 lines of code. That's about 13% of the file has changed within the past year. I don't publish this number a lot. This is a lot of code churn for a project that people consider to be very mature. And when people hear this, release managers in particular are very nervous. But because we have such an intensive test suite, mostly written in Tickle, we're able to make large changes like this without breaking anything. So that's our current status. What's new? What's new in the project? This past year, there's long been a mailing list run by the Mailman program for SQLite. We turned the mailing list off this year, and now interaction with the developers and the community is done with a forum run using the Fossil program. There was a lot of pushback on that, but the forums turned out to be really good. Page 7. The forum makes it so much easier for anonymous passersby to post things. And we've gotten a lot of anonymous posts, people reporting bugs or problems that we probably would have never heard about had the people had to go through the trouble of signing up for a mailing list. Now, the forum does give you the option of receiving email notifications. So it works pretty much like a mailing list. The big difference is that you can't reply to these posts. You actually have to go to the website and type into a form in order to send a message. That's the only difference between a mailing list. But the other advantages, the messages are nicely formatted using Markdown and the new graphics language Picture. You can, if you make a mistake and you post your message and you later see the typo, you can go back and edit it. Built-in full text search. You can download a complete copy of the entire archives by cloning the repository and view it offline. And a big advantage is that the Fossil Forum doesn't require that I install Python and Apache on the server. So page 8. Another big change we've made this year, at customer request, we've increased the maximum database size of SQLite to 281 terabytes. Now that maximum assumes that you're using a 64K database page size. If you're using the default 4K page size, the maximum database size is 17.5 terabytes. We don't know of anybody with a database that big yet, but we do have one customer who has a 2 terabyte database, and it's growing, and they wanted some additional margin, and so we increased the size a little bit for them there. Now, this is the largest, this is as big as we can go without a fundamental file format change, and because SQLite is an interchange format and an archive format, we're reluctant to do that. So this is probably the hard limit, but we'll see what we can do moving forward. We've added a new SQL function, the if function with 2 I's. This is taken directly from SQL Server. If you've done any programming on SQL Server, you're probably familiar with it. It is semantically identical to doing a case statement in standard SQL. It's just a new way of saying it, and it generates exactly the same bytecode, runs just as fast. It's just for people with prior exposure to SQL Server, it's easier for them to understand. The Pragma's function list and module list and Pragma list are now all available by default. It used to be that those were compile time options. They were off by default. And now, and then we also have this new feature where you can set a limit on the size of an analysis. This is going to be page 9. So one of the key unstoppable ideas in SQL, and Karl alluded to this to his introduction, is that as a programmer, you don't have to define the algorithm. You tell the computer what it is you want to query, and the computer comes with or the database engine comes up with the algorithm itself. And this is really, really powerful concept. This applies to all SQL database engines, not just SQLite. But it allows you to do far, far less code. And if you accept the hypothesis that the number of bugs is approximately proportional to the number of bytes of source code, this results in far fewer bugs. You as a programmer get to spend more of your time working on your customer's application and less time worrying about the details of querying stuff from the disk. And finally, you can change the algorithms late in the development process. So suppose you're developing some big product and it's going to be released next week, and then in testing you find some inefficiencies, running too slow. If you wrote all the algorithms yourself, that means you have to go in and redesign the algorithms and recode, and that can be time-consuming. You've got to go through testing, and you're going to delay the release. But if you're using SQL, you can often fix the performance problems simply by typing create index, and you don't have to recompile, you don't have to rebuild, you don't even have to restart the application. It just suddenly starts running faster, and that's an amazing thing, that you can change the application just by creating an index. So, but this query planner that picks the algorithm, we call it an AI because it's having to work with incomplete data. It has to guess at what the best query plan is. And there could be hundreds, thousands, even millions of possibilities that it has to choose from. And the only way to get a precise answer is to try all the possibilities and see which one runs the fastest. That's obviously not going to work because that would take more time than just running one of the queries. So it has to make a guess based on incomplete information. It follows then that the more information it has at hand, the better it's going to be able to guess. And in SQLite and other database engines, you can there's a command called analyze, which scans the database file, especially the indexes, and gathers statistical data, how big the index is, how selected the various fields are, how big the various fields are. And then the query planner is able to use that to make a better guess or better judgment of what the fastest query plan for any particular query is going to be. The problem with that is that running analyze can be expensive for large databases. Now, if it's just 10 or even 100 megabytes, it's usually pretty quick. But if you're in a 2 terabyte database, it can take several hours to run a full analyze. And so that's been a big problem with people with very large databases where the query planner algorithms are most important and it's expensive to run analyze. So we've got a new feature now where you can run a partial analysis. If you set pragma analyze limit equal and then some number, and I recommend a number here between 100 and 1,000, it only looks at the first 100 or 1,000 or however many specify entries in each index. And 100 entries in an index will fit on one page of the database file usually. And so this runs very, very quickly. And so and the results are not quite as good as doing a full analysis, but in most cases they're good enough and it runs very quickly. So now what we recommend that you do is whenever you close a database connection on a long-standing project that's using a long-standing database, just before you close the database connection, you should set analyze limit to 100 and then run pragma optimize. And what pragma optimize does is it checks to see if any of the queries you've run during the current session would have benefited from having run analysis before. And if so, it will run an analyze on those specific indices. Usually it does nothing, and so pragma optimize is very close to being a no-op. Sometimes it might run an analysis on 1 or 2 indices, but if you set analyze limit to 100, that's going to go very quickly. And if you do this, you're much more likely to get very good query plans, regardless of how complex your queries are, and regardless of how the shape of your data is changing over time. On to page 11. What else is new? We have recently added syntax to provide on an order by clause, you can say nulls last, and that moves the nulls to the end of the sort. By default, SQLite puts nulls first on an ascending sort. On a descending sort, it puts nulls last. And so you can also say order by blah, 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 descending nulls first, and it will then move the nulls first. So that's a nice feature to have if that's important to you. Another new feature we've added is support for generated columns, and this is going to be page 12. A generated column is a column in a table that is computed from an expression. I've got 2 examples here. Create table T1. They both generate the exact same table, but one of them has some additional syntax words that are supported by the generated column idea. The generated always keywords are optional. Really, it's just looking for the as in the expression. There are 2 generated columns here. There's D and E. The D column is virtual. That means that's computed as it's read. And the E column is stored, which means it actually takes up space on disk. So generated columns is a standard SQL feature. The expression in a generated column must contain only literals and columns and other columns in the same row. You can't refer, the generated column expression cannot refer to the row ID. It can use functions, but they have to be deterministic functions. It can't use a function like random. And the generated columns can refer to other generated columns, but there can't be loops in the dependency graph. So they ultimately, when you follow the dependency graph of the generated column expressions, you have to resolve to just literals and other columns. Interestingly, Postgres does not allow generated columns to refer to anything other than real columns, and MySQL, if I have this right, requires that if a generated column refers to another generated column, it has to come earlier in the table. SQLite is completely general as long as you don't have loops in the dependency graph. You can use a generated column anywhere you can a regular column, inside queries, inside constraints, including check constraints, in expressions on indices, on the expressions on a partial index. You can use them there as well. But you can't set the value of a generated column. at least not directly. You have to set the value of its other of the columns from which it is computed. And for right now, we don't allow a generated column to participate in the primary key for a table. We might relax that constraint in the future, but for right now, that's in place. And you can't have a default clause on a generated column, because that would be almost like setting the value of the generated column. Oh, and one final thing is every table must have at least one column that is not a generated column. Well, why would you use this? There's a lot of reasons. We did this for a customer request. One that came up just the other day is that something that a lot of people have been interested in lately is having checksums in their database to verify that the data doesn't get changed on disk, that their SSD doesn't take a cosmic ray hit and change 1 or 2 bits somewhere in the middle of some field. So one approach to doing this would be, I've got a table called data, and it has a primary key, which is an integer named ID, and it's just text content. It's just a key value table. But I've added a generated column, which is the SHA-3 hash of the combination of the integer identifier and the content. And I added a check constraint that verifies that that hash is correct. It's a stored generated column, so that it is actually stored on disk. And so if you did something like this, and you wrote your table out to a cheap eMMC device or something like that, where it might be prone to taking bit errors on the storage device, you could run pragma integrity check, and the check constraint would immediately find if any bit had changed anywhere in the table. It's an interesting idea. So there are other uses for generated columns. That was just one example. We're on slide 16. Another new feature we've added in the past year is the support for update from. Slide 17. Update from allows you to add a from clause to an update statement, so that the expressions for the values you're inserting into, or that you're modifying in the table, come from a join. Now, update from is not standard SQL. Most other database engines support it, but they all support it differently. And so we elected to follow the Postgres syntax, which means that the table being updated is not included in the from clause, but it's sort of added to the beginning of the from clause as a comma join. Let's go to slide 18. Another change, and this last change I like the most because it solves a problem that I personally had, will be in the next release. And it is the ability to have multiple recursive selects and a recursive common table expression. Let's go to slide 19. Do you know about recursive common table expressions? This is standard SQL. I think all the major database engines support it now. It's a way of doing it's not truly a recursive computation, it's actually iterative, but it first runs it's creating a transient table, which here in this diagram is called CTE. It runs the initial select to begin populating it, and then it iteratively runs recursive select to fill it out. And then that transient table can be used in the select, insert, delete, or update table that immediately statement that immediately follows. So slide 20. Here's slide 20 shows an example of how to do a query that returns all integers between 1 and 1000. So the name of the CTE is C, and the initial query is just a value 1. So we seed the table with 1, and then the iterative query adds 1 more than the previous value, and it just does this until we get up to 1000. And you can type this into SQLite or most any other database engine, and it will give you 1000 rows with a different integer in every row. So the new feature is that in many implementations, that recursive select, there can only be 1 in the query. Slide 21. But I needed the ability to do a query against an undirected graph. And so here, as an example, I've created a table called edge, and this defines an undirected graph, which shows an edge going from node AA to node BB. And I've got a couple of indexes there for performance. They're entirely optional. And I want to find, in this example query, I want to find all the nodes that are connected to node 59. I want to query for every node that is connected to node 59 through any path. And presumably the connected components of node 59 are small relative to the total number of nodes in the graph. So the initial part of the query begins by seeding the nodes table with 59, but then I've got two recursive selects that follow. One of them follows edges in the direction of BB to AA, and the other one follows AA to BB. And the other thing is that I'm using the union operator rather than the union all operator to connect these. And that the union operator means that there will be no redundant entries in nodes, and that keeps us from getting stuck in a loop if there are loops in the graph. And so this runs very quickly and will show you all the connected components of a node. This came up for me while developing Fossil. And on slide 22, we have an eye chart, which is the actual query that I needed this support for, where I wanted to find all of the files that are derived from a particular file, either by edit or by name change. And this is a query that has two recursive selects and a recursive common table expression. And it's, some 20 lines of code. It's a complex query that touches many different tables. Going back to what Karl was talking about, this gives us the ability to see all the changes of a file in Fossil, both across edits and renames. That ability does not exist in other version controls, or many other version control systems, because they don't have an SQL query capability. In order to do this, you could do this in Git, for example. Git has the same underlying Merkle tree data structure, but you would have to code this out by hand, and it would be thousands and thousands of lines of code that you would have to debug and, more importantly, maintain long term. With this, it's just a simple query. So let's go on to slide 23. We're back to our what's new list. We've got a lot of enhancements to security. I've got a whole section on this. I'll come back to them in a minute. Let's go to slide 24. We've got some new extensions. The checksum VFS, this is not built into the SQLite amalgamation. You have to compile it and load it separately. But the checksum VFS is a back end to SQLite that tells us that actually computes a checksum for every page of the database file and writes it into the file as that page is being written. And then as pages are read back out of the database, it verifies that checksum, and if it's incorrect, it will throw an IO error. This has come up multiple times. A lot of people are suddenly very interested in this, and I don't understand why. Maybe somebody can clue me in. Another thing that has come up is that all of the people who have contacted me with interest in this are located in Germany, and I don't know if that's a coincidence or if there's some new legislation in Germany where this is important. I don't know, but it is available now. It works, and you can load it separately. We've also added new extensions, decimal and IEEE 754, and that's going to be slide 25. These are extensions that allow you to do decimal arithmetic. We get a lot of people complaining that they put a floating point value into an SQLite database and it doesn't remember the number exactly. Well, that's because floating point numbers are approximations, and SQLite does not have the big num support that TCL does. So we've got a series of functions that allow you to do arithmetic on decimal numbers that are stored as strings. And here's an example where I've got a query that it's going to take the floating point number 47.49 and compute its actual value as it's stored in an IEEE double. And as you can see, that actual value is very close to 47.49, but it differs very slightly. Now, if you were running TCL, you could just do format. You could do a format statement and find this out very quickly. But it is possible now to do it in SQLite without using TCL, using this extension. Slide 26. We also have a new bytecode virtual table. If you have a prepared statement in SQLite, you can pass that as a parameter to this SQL function. And this is a table valued function. You put in a prepared statement as a query, as a parameter to this table valued function, and each row of the table valued function is going to be an entry in the bytecode that actually implements that query. We've got a UUID function that just formats UUIDs in the standard format, and we have a new SQLite DB data virtual table. This is a virtual table that treats the entire database file as a key value store, where the key is the page number and the data is the content of that page as a blob. And this is a read-write table. So if you write to this, you're actually physically changing the bytes on disk that implement the database file. You can obviously corrupt your database file very badly with this, but it is available if you want to do some interesting things. Slide 27. The command line tool for SQLite is not considered purely part of SQLite, but it is part of the project, and we've made some enhancements there. The new output mode called box is one of my favorites. I think that's going to be slide 28. Yeah, if you do mode box, when you do a query now, it uses the ASCII art characters, or not ASCII art, it uses the extended Unicode box drawing characters to draw neat little boxes around the table that results from your query. Let's go to slide 29. There's also new output modes for JSON, for Markdown, for table. Table is the same as box, but it draws the boxes using ASCII art, which is what MySQL does. And of course, there's also the output mode quote, which really should be the default. When I was inventing the command line tool, I tried to emulate the PG command line tool, PG SQL command line tool, and they do something different, and I should have just done quote. But anyway, we've got some new built-in extensions in the command line tool. The generate series table valued function is there. uint is a collating sequence that sorts text, but if the text has embedded numbers, it puts those numbers in numeric order. And then the decimal and IEEE 754 extensions are there. There's new dbconfig, new recover and parameter commands. A little short on time, I'm going to skip over those. Page 50. Excuse me, page 30. One of the big things, we've spent a lot of time improving the defense of SQLite against attackers. Let's go immediately to page 31 and let me define the problem that came up. Some hackers found a new vulnerability in SQL in general, but in SQLite in particular, which is very interesting that you need to be aware of. Suppose in your application that you're defining some application-defined functions. And in this example, I've got an application-defined function that runs a command. It takes the arguments of the SQL function and runs them as a command in a shell. It's the equivalent of exec in Tickle. In fact, that's how it's implemented here. And then suppose you also, whenever your program starts up, it reads from some table, and here I've just said event log. It's going to do a query against event log. And you think, that's fine. I'm immune to attack because I'm very careful to avoid an SQL injection. Nobody can attack my system. But wait. Some very clever people figured out a way that they can attack your system without using SQL injection. What they do is that they can get a hold of your database file. They can go in and they can rename the event log table to something else. Here I've called it copy event log. And then they can create a view named event log, which queries this copy of the table that they created, but also invokes your shell function. And so if they corrupted the database file in this way, and you tried to open it with your application, everything would work as it normally had worked. But when the application finished, you'd find that all of your files were gone, which is a very troubling prospect. So how do you defend against this? Slide 32. We've added a new parameter to application-defined functions called direct only. And what this does is it prevents that function from being used unless it's used directly in top-level SQL. You can't use it in views, you can't use it in triggers, you can't use it in check constraints, you can't use it in indexes on expressions. It has to be SQL that's coming directly from the application, and that would completely shut this attack down. Slide 33. Another thing you could do is turn on a new mode called turn a mode called Trusted Schema off. Now, really, we should have Trusted Schema off by default, but for legacy compatibility, we have to leave it turned on. With Trusted Schema turned off, no application-defined functions or no functions of any sort are allowed to be used in triggers and views and or anywhere unless they are first tagged with innocuous. And there are a few built-in functions like, say, absolute value, ABS, that are tagged innocuous, and you can use them all you want, even if trusted schema is off, because who cares if the attacker runs an absolute value? It doesn't have any side effects. It's not harmful, but it automatically makes all of your new application-defined functions unusable, except it from direct top-level code. Let's go to slide 34. Another thing you can do is if your application doesn't actually use views anywhere, you can turn support for views off, and that would prevent the view from actually being used. And if your application doesn't use views, I recommend this. Slide 35. You can also turn triggers off. If your application is not using triggers, it makes sense to turn them off. We also have a mode called defensive, which we recommend that you turn on. What defensive does is it disables certain features that would allow an attacker to intentionally corrupt the database file, such as it disables the SQLite DB data virtual table, which would allow them to deliberately corrupt the database file. And finally, we have a feature called hard heap limit, where you can set the hard heap limit to, say, 1,000,000, and this prevents SQLite from ever using more than a megabyte of malloc memory from the heap. If it tries to go beyond that limit, it'll start throwing out of memory errors. So with these things in mind, slide 36, the key takeaway here is that it was discovered that a database schema contains executable script, or can, in the case of views, check constraints, and that sort of thing. And so if you have a database schema that is accessible to possibly hostile users, you need to take steps to make sure that schema is secured, or that any changes or any part of that schema, running a script in that schema, is going to be harmless. Slide 37. In summary then, SQLite is still one of the most widely used software libraries in the world. It's fast, secure, featureful, recommended by the U.S. Library of Congress, well documented, and we intend to support it for 30 more years. So, questions. Question number 1, why aren't you using SQLite more yourself? Question number 2, why isn't SQLite compiled into every TCL build by default? Why do we still have to do package require SQLite? And 3, why don't we have a TCL.c amalgamation file like we do for SQLite? It would make TCL so much easier to build into existing applications. And then finally, I'll open up the floor to questions and concerns from the audience. Thank you for your attention. Do we have any questions? How does this work, Violet? This works way better. This works way better when we're all in a room together. I'm sorry that we can't meet in person.
All right, so the attendees actually can ask questions both in the Q&A option.
Do I need to open that Do I need to open that up?
Yes.
Okay. Q&A is open. And I'm not sure what I'm supposed to be looking at.
Alrighty. So I believe Judy pinged you with a list of questions that are available for you. We were collecting them behind the scenes and made them available for you. If you can refer to that.
Nathan is asking what's on the bookshelf behind me. There's some Tickle books back there, Gerald. The row of Bibles is actually off screen over here on this side. You can't actually see that. I do have that, but there's several books on Tickle up there. There's several books on SQLite. There's a bunch of O'Reilly books. What else do we have? So, Violet, where do we go from here? Do we continue trying to take questions, or we're out of time? Do we just move on to the next talk?
Yes.
Correct me. Help me out.
I was actually going to take over after your presentation to just go over some quick, get familiar with the actual Zoom format. So if there's any questions, I want to make sure that Actually, we have some questions coming in, so we can actually send them over to you. They're in the Q&A part.
Okay, I've got to click on open. Here we go.
There we go.
What are your thoughts on making SQL more composable? And Nathan, what do you mean by that? That sounds like a big question. That sounds like something we need to talk about. That sounds like a more involved conversation that we're going to have later. I don't really even know what it means. I have used auto hotkey for years. Is TCL like A8? I don't know what that means either. Have you considered adding graph query sugar like connected by? This is from Don Fellows, and yeah, that we originally put in recursive common table expressions at the request of Oracle. They were a customer of ours at that time, and they were originally requested connected by, but connected by is not standard SQL. And so we came back to them and said, well, can we do the standard SQL common table expressions instead? And they said, oh yeah, sure, that'd be fine. And so that's what we chose to do. So the reason we don't do connected by is that's an Oracleism. And then somebody else writes that connected by has been deprecated by Oracle. So the official way to do it is by the recursive common table expressions. Yes. Are there any more questions coming in?
No, I don't think there's any more questions. Does anyone want to ask a question? Actually, one more came in.
Yes, that's, Kevin asks, are there plans for more complete spatial support? You know, there is that separate project called, is it SQLite? It's a separate project, and they take our code and they add a bunch of new functions and do that. And I'm not going to compete with them. I've got enough to do as it is. You know, one thing, Tom Poindexter has a question too. You know, one of the things I wanted to bring out was when a lot of times when I give a talk and afterwards people say, that's great, Richard, but what do you do all day? I was hoping that my slide showing the 13% of the code base change from year to year would help to answer that question. We're actually very busy here. We make a lot of changes, but no, I want to try avoiding that. I want to avoid having to do the spatial stuff myself if I can. Do you think C will also be around in 30 years, or at least favorable enough to build system software? I think so, Tom. What do you think it's going to be replaced by? People keep telling me, oh, you should recode SQLite in Rust, but I'm skeptical of that. I mean, for one, well, we can talk about that later. I've got a whole, there's a documentation page, there's a documentation page on the website on why SQLite is coded in C. And you can, if you go to the search bar, it'll take you to it. I don't have the URL off the top of my head, but go and look on that. And then Ivan asks, what's the secret for keeping a large C code base so clean and working well? Writing lots of Tickle tests, or TCL tests, excuse me. Writing lots of tests in TCL. Discipline. Don't take every pull request that comes in. Insist on good comments. That would be my quick summary. Okay, we're way over time. I think we need to flip back over to Violet and let her tell us what we're going to be doing next.